Welcome back, everyone. We're going to dive in and do some calculations now. First question. The distance between the centers of two mass pieces. Here, it doesn't matter really what the mass pieces are, but they're mass pieces, they're just weights, is 6 kilograms and 4 kilograms, and they are 3 meters apart. They want us to calculate the magnitude of the gravitational force that they exert on each other. Magnitude means it can only be size. Direction is not something I need. The thing with Newton's law of universal gravitation is that the direction's always attraction. We need to be a little careful with the way the question's worded when we put direction, but here, they only want size, they only want magnitude. Remember as well that you can't get a negative value for this equation. If you do, something's gone wrong, and you need to relook at what you've done. Okay, you can't get negatives. How do we do this? So we have the two centerpieces. This is what we're saying. We've got a mass, which is 6 kilograms. We've got a mass, which is 4 kilograms. And the distance between them is 3 meters. I want the gravitational force. As soon as I see that, I know I'm using Newton's law of universal gravitation. So F equals G m1 m2 over r squared. Do you need to remember this equation? No, because it's on your information sheet. But hopefully, if you practice enough, you'll know it in your head. Okay? Now we need to do the substitution. Big G is a constant. It's given to you as well, and that's 6,67 times 10 to the minus 11. Ish, we don't like that, but it's fine. My masses are both in kilograms, so it's going to be 6 times 4, and now the big MB. It's 3 meters squared. I see this all the time. The square gets left off. I don't know what it is about the square, but it gets left off and it gets forgotten. It feels very lonely some days. Please don't forget the square. Often what you'll do is you'll write the equation with the r squared because you take it off your information sheet. Then when you do your substitution, the square goes on holiday. You're going to get the wrong answer. You need to make sure you put it in there. Now we need to put this in our calculators. Before I do that, you also need to make a decision. Looking at the values that you've got two small masses, 6 and 4, tiny. 3 meters apart, they're actually quite far apart. That means that I'm expecting to get a small answer. So before I even do the calculation, I'm going, what sort of answer am I looking for? Because that gives me an idea when I get to the end as to, did I get the right answer? So, here we go. We have, and I know I do this slightly differently to the way you guys use your calculators, but it doesn't matter. 6.67, and it's going to be times 10 to the minus 11. I'm going to times by 6, times by 4. I get an answer, and now I'm going to divide, and here's the trick, 3 squared. Don't forget about the square. And look there, this is tiny. Final answer, 2 decimal places, so this is going to be 1,78 times 10 to the minus 10. 1,78 times 10 to the minus 10, and it is newtons. I don't need a direction, they didn't ask for it. It's very small. This isn't even a force that you would be able to experience. You wouldn't even notice that it's there, but it is there, okay? And both objects, both mass pieces are feeling the same force. Newton's third law. It doesn't disappear because now it's two small little objects. This gravitational force is a field force. It can act over a distance. We don't have to have the objects right on top of each other. You get it? We thinking through it? Let's do another question. All right. The centers of two identical balls. That identical means that they are the same in every way. They are the same physical shape, so they have the same volume. They're made out of the same material. They have the same mass. Everything about them is the same. That means I'm telling you that mass 1 is equal to mass 2. We're going to use that. They're situated 1 meter apart, and the gravitational force between them is 6,7 times 10 to the minus 9. That's quite small. We're good with that. What they want is the mass of each ball. So, let's get to the equation. We know that we're going to be using F equals G m1 m2 over r squared. Now we've got to look at how we substitute this in. Because the two balls are identical, I'm going to go mass 1 is equal to mass 2, and I'm just going to make that m. When I use the subscripts 1 and 2, I'm saying they're two different objects. By saying that those objects happen to have a mass of m, I'm making my maths a bit easier. Let's substitute in what we know. 6,7 times 10 to the minus 9. We have to use G. 6,67 times 10 to the minus 11. Now I've got m times m, and my distance is 1 squared. We like it when they use 1. It's an easy one. I'm now going to manipulate it because I need to get m on its own. Okay, so m times m is m squared. I'm going to divide both sides. 1 squared is 1, so I can ignore it. I'm now going to go 6,67 times 10 to the minus 9 divided, 6,7 times 10 to the minus 9. We're going to divide it by 6,67 times 10 to the minus 11. Ooh, that's an 11, by the way. There we go. That's the first thing I need to find the answer to. So calculator, and we go 6.7 to the minus 9 divided by 6.67 to the minus 11, and I get 100,449,751. I don't want that value because that is the square. I want, whoopsie, just m. So I need to take this value, and your calculators are great because it stores that last one, that last answer, square root of my answer, and I get 10,02. Okay? Was that right? I think I missed out. No, 0.2. Yep. See, you've got to make sure you look at your calculators properly. It's very easy to make a mistake like I just did, and we want to avoid that. So that's 0.2 units. We've got a mass, kilograms. What are the mass of each ball? 10,02. I don't need to do anything else after this. Remember, if I get a negative answer, I've absolutely made a mistake. So make sure you keep that in your mind. Both masses are the same because they are identical. Not the nicest maths, but it's okay, we can do that. Hopefully this wasn't too bad. We're going to take a short break and I'll see you in a couple of minutes.